Okay, welcome to workshop number 3, Grasshopper tutorial. In this one we're going to do an attractor circle, and then we're going to extrude those circles. So some of the key points we'll be working with is how to create an attractor to change the radius size of a bunch of circles. So I will work off of this built script down here like we did in the last one, and I'll just go piece by piece. So if you remember the last script where we did the pictures of the penguins, if you missed that one, you can go ahead and check that one out on the server. If not, we'll just build this one from scratch. You should be able to follow along just as easily. To begin this one, in the same way that we needed the last one, we need to create a grid of points. And the easiest way to do that is to create 2 series components. So again, series is under sets, sequence, series. And you just click on that, drop that right onto the canvas. The default is from 0 to 10, and what that means is the start value is 0, the step size is 1, and the count is 10 in the default. So what we need are 2 sliders, and the sliders live underneath parameters, special number slider. Click on that number slider and bring that down, and then to reset the settings for the slider, again you double click on the word slider. You can change this to number of points X, and you can change the other one to number of points Y. Oops, sorry. And what you want to do is leave the min at 0, change the max to 50, and we can set the value to 20 like I have in the other 2 sliders. So what we'll do is you can also right click on this to rename it. So we'll name this number of points X, this one number of points Y. And this is just to keep your script organized. It's going to get really helpful once you start getting a lot of components in here. Okay, and you're going to take that and plug those 2 into the C component of the series. So this is our counter. If you just hover over the S, you'll see that it counts from 0 all the way up to 19, and that's 20 full numbers. And then what we need to make a point grid is we need a point. We need to create points out of these numbers. So the point is again under vector point XYZ. Click that, drop it on the canvas. If yours doesn't have this S, it's because I'm using the latest version of Grasshopper. If you're interested in finding out what version you're using, you can go to help and then about. And right here it says 8.80065. I believe this is the most updated version, but either one will work. The old one just doesn't have this S. This is asking for the coordinate system for the point. We'll just leave that as a default value. So for X and Y, you need to plug our first series into X and our second series into Y. And you can also rename this X points. Rename this Y points. You can rename the point grid. So again, what you might have with the default value, if you preview this, is a diagonal line. And this is what happened in our last script. What you need to do is right click on point grid and change it to cross reference, so that it asks for each one of the first points against each one of the second points and continues to sample those points off of all of them. Okay, so once you have that set, right click, cross reference, you should see this big grid of points. I think it should be 400 points because we're 20 by 20. And then the output of the point component is all the XYZ values of your points. Okay, so let's move this over. Alright, so what we want to do is we want to find, we're going to draw a line between this first point and this last point, and then our attractor is going to run along that line. So what we need to do is get this point and get this point, and we need to draw a line between the 2. So what we can do to get the first point is a list item. We can pull out that specific item. So under set, list item, drop that down here. And what you're going to do is plug the point grid into the list. So all 400 points are here under L, and then I is your index. So the index is the We'll put a pen on here to show you. The index is the number on the left. See this 0, 1, 2, 3, 4, 5, 6, 7. So each one of these has their own index. So if you put in 6 in I, you're going to get this 6th point. And I'll just show you how that works. So right now I just put a slider in there, and I put the range, the min to 0 and the max to 400, so that I could sample through all 400 points. This can get pretty tedious after a while if you have in the thousands. So if I preview this, I think I might have to change my solution. Oh no, we're good here. So what you see is just this first point, and then if I pull this slider, what it's going to do, this computer's a little slow, but you'll see it jump around to different points in the list. It's sampling through all 400 points in a row because the index is moving through each number. So what we want to do is set this slider just to 0. And if your computer starts slowing down, like mine is, instead of trying to pull the slider through the numbers, you can just simply double click right here, set your number, and then hit OK, and that'll be a much faster way to do it. So now that we have the first point, we need the last point. So intuitively, you would think that you could just search the index for the 400th point. But in this case, since our lists count from 0 to 399, we don't want the 400th point, we want one less than the 400th point. So what you could do is you could just hard code this, right click it, and come down here to set integer if you don't have anything plugged in. And you can set that integer to 399 and you get the same point. But a more efficient way to do it is to find the number of values in the list and then subtract that by 1. So anytime you ever change the size of your series, if you ever want more points, it will always find that last point. So for that, what we need is a list length, which is a really helpful component. Under sets again, list length. And the list length is just taking any base list and it's counting the number of values. So it's just exporting the number 400. And there are 400 numbers in our list, but we want number 399 because Grasshopper starts its indices at 0. So what we need to do is come down here to the I, and if you see this little asterisk, this means that there's an expression, and to get that expression, to set that, you right click on I, you come down here to expression, you can open up the expression editor. So it's going to pull up this big dialog box, and in here you can write custom formulas to run different expressions on your numbers, on your data. In this case we need a really simple one, just I minus 1. So all this is taking is it's taking any input you give it and it's just subtracting one number from it. So in this case it's taking the length of our list and it's subtracting one number to get the last item, number 399 in a 400 number list. If this seems confusing, it'll get a little bit easier. So again, that's right click on I, expression editor, and just type in here I minus 1. Hit OK, and you should pop up with this little expression thing. And then what this is going to do is if you preview it, it will give us the last value. So turn our point grid on, highlight these two, and you see we have the first value and the last value. So from these two values, all we want to do is create a line. And this is pretty simple. You just get a curve, primitive, line, drop that onto your canvas, and then just A and B, where do you want it to go from? So let's call this last point to keep them organized. This will be first point. Okay. You plug those into the line, you can preview that line, and now we just have a simple line in between our first point and our last point. Okay, but what we want is a vector along that line. We need a point that we can drag along that line as our attractor. So attractor can go all the way through our field of points. To set that, what you want to do is, this component is called evaluate curve, and this lies under curve analysis and then evaluate curve here down on the left. It says evaluate a curve at the specified parameter. So when you drop this on, you'll get something that looks like this. It just says eval. What it's asking for is the curve to evaluate. So we can go ahead and plug our line into that. And then it says parameter on the curve domain to evaluate. It seems a little confusing, but it's pretty simple. You just have to give it a number. In this case, we can just drop a basic slider. You don't have to change any of the settings, just from 0 to 1. Plug that into T, and what you'll see here, it's going to go all the way from 0 to 1. In this case, because we have a set distance for our line, we don't have to change anything. We don't have to reparameterize what it's called, but we're going to do it anyway, because if you have a surface or something with a larger domain, you're going to want to reparameterize. So what that means is right-click on C, you'll come down here to reparameterize, and you'll click that. You'll get this little parabola curve. All that's doing is it's resetting the domain of this line from 0 to 1. So it doesn't matter what the domain is, it's going to reset it to 0 to 1. So what's helpful about that is if I want to set this to 0.5, let's say I just want halfway through the line, it'll immediately go directly halfway through the line. And that way I can set it to 0.75, 0.75. So in this case it's reading it from here to here. If we want to change that, I believe we can reverse this. Maybe not that one. You might have to reverse these two numbers. So your first point is A, and your last point is B. And there we go. Okay, so if your line was down here at 0.75, you can just reverse the last point to B, first point to A. It's better, obviously, to have it start at the first point. You can also rename these inputs if you want to. So we could call this first, and we could call this second or last. But be really careful, because if, in the case back here where we had I minus 1, if you were to rename that I, which I'll show you, we'll just rename, we'll rename I to B. It's going to give you a different value because it's not going to read. It's reading when it says I minus 1, you have to type in B minus 1 because it's going to read the wrong value. It's going to read whatever this string is here, this letter. Okay. So if we go back down here to evaluate, now we're reparameterized and we can swing all the way along that line, that little point. This is going to be our attractor. So we can just call this radius attractor. Okay, so I'll delete this since I already have it up above. Same thing. So if you have a surface and you're interested in getting exactly halfway through the surface, the same thing, you can double click on here, 0.5, and it'll go directly into the center of the line. Also directly in the center of the surface, whatever you have and whatever you're evaluating. Okay, so the way that we need to get our radius, as we did before, is we need to find the distance between, I'll turn the points back on, right click, preview. So we need to get a distance between every point and this attractor, and every point and this attractor. So that way when that attractor moves, the distance between those points is going to move, and that distance is going to affect our radius. So we can unpreview these, highlight them, scroll wheel click, disable preview. We can leave the line on for now. And what we're going to need is a distance component. And the distance component, I believe, is under not sure actually. Curve, utilities. I have to find this one quick. Huh. Where do they put that? Sometimes they move these around in the different versions. Build, extend, curves. Okay, it's under vector. So you go to vector, point, and then distance, and it just says compute Euclidean distance between 2 point coordinates. So drop that on here. It's just asking for A and B. In this case, A is going to be all of our points. So we can drag that and drop that into A. B is going to be our attractor location, and that's going to give us all of the distances between the points and the attractor distance. If you want to put a panel on here, take a look at those distances. This is for all 400 points, give you that exact distance. Okay. So from here, what we want to do is plug this distance into our radius function. And the radius function is actually just a division function, because right now our numbers are really big. So this would be 13 inches, 12 inches, 12 inches, 11 inches. So if you come up here to Math, Operators, Division, it'll look the same. I just renamed it radius a while. So you'll take your distance and plug that into A, and then whatever number we want to divide it by. So in this case we need a slider. And I believe I set mine from 0 to 30 and just set the value at 20. So if you copy this panel, you'll see that all of these distances have been divided. So these are much better radiuses that we can work with, much smaller values. So this will be really helpful. I'll delete this. Okay, so once you have this, you can rename it radius, and these will be all your radius values. And then we need to create circles for all these radiuses, or any type of polygon. In this case, we'll use any type of polygon, so you can really play around with it. So to get the polygon component, you come up here to Curve, Primitive, Polygon. You'll drop the polygon right onto the canvas. And then what the polygon asks for is polygon base plane. So the base plane is going to be our points. And the reason it says base plane is it just needs to create an XY plane at a certain point. And because our points are just on the 0 axis, they're all going to be on the XY plane. So we can just plug our original points all the way from back here into that P. And then our radius is R, so come right out of our radius function right here. And S is the number of segments, or the number of sides, so we can put down your number of sides. So you're going to need another slider, and you're going to put this as a numeric slider, and max I have is 30, which is way too high because you don't really want a 30-sided shape. 15, and set it to 3, so we're going to get triangles. So when you plug it into this polygon, what you're going to end up with is this, and it's more helpful to see if you turn off the point grid. So right now you should have triangles that are much smaller when they're closer to the attractor point and much bigger when they're further away from the attractor point. And then what's cool about this is you can play with the radius. Mine's going to be really slow, but they'll get bigger or smaller the more you pull that. And then you can also pull the attractor point. I'm just going to set mine to 0.75 for speed reasons. And then as it moves, it's going to move those attractors with it. So you successfully have set up the attractor. And now you can come back here and turn the preview of the line off. And you can even turn the preview of the attractor off if you want to. And this way, every time you move this now, 0.25, it'll move all of those and scale the radiuses accordingly. So what I think is helpful is to highlight some of the most important parts of your scripts. So in this case, this one is really important. This is our slider for our attractor. And I also think that this radius is really important. So this is just Control G again to group it. So that way when you're moving around your script and you have a really, really long script, you can find, oh, okay, here's one of the things I really need, here's another thing that I really need. These are important parts. And also the polygon you can highlight as well. So then again, with these you can come in here and go down to color, and you can always change the color to whatever you want. And you can also right click on the group and rename it. We can just call this polygon sides. Okay, so what we're going to do now, you can stop here if you want to because you have your attractor done, but we're just going to add a couple more components, and what we're going to get is 3D view. So these are going to have a 3D extrusion. So what I'm going to do, I think I'll make mine a pentagon. So we'll go to 5. So now I have a whole bunch of pentagons. And we're going to create planar surfaces out of this, and then we're going to extrude those surfaces. So to create planar surfaces, you'll go to Surface, Freeform, Planar Surface, which is here. Create a planar surface from a collection of edge curves. Since we have closed edge curves, they have to be closed. You can't have an opening in them, but most of the stuff coming out of Grasshopper will be a closed curve. So you'll come to a planar surface and you'll drop that. And then it's just asking for the edge curves, which are simply our polygons. So plug the polygons right into the edge curves. And then when you preview this, you're going to end up with a whole bunch of surfaces, a whole bunch of planar surfaces, and this will work the same way as you pull the attractor. They'll change just the same. What we want to do is extrude these, so we have sort of like what's an organ. Kind of looks like an organ if you have cylinders, but in this case we'll have a bunch of pentagons extruded, and we're going to extrude them based off of the distance from the slider as well. So if you come here and you get an extrude component, which is under Freeform, Extrude,